There's two of us that are going to speak tonight, myself, Bob Schulein, and Dan Mapes Riordan, who I'll introduce a little bit later when his part of the presentation starts. So, here's an outline of what we'd like to talk about. Some introductory remarks on 3D audio, presentation of the demo system we have here, important area which is trends in 3D audio technology, an update on what Dan and I have been doing with immersive. We've had a talk on that specific subject before, and some immersive demos that we'll do here with the earphones and the screen. Some summary thoughts and conclusions, and then a breakout session where we have 3 setups out in the hall that I'll explain, where you can listen with wired headphones and also with some loudspeakers. And if you brought your own headphones, you can plug in as well. So, the word 3D gets thrown around a lot, kind of a buzzword. So, from my perspective, a definition of 3D audio would be an audio system or impression in which sound could come from virtually anywhere, hence the word 3D. We're all very familiar with things like 5.1, which is a horizontal plane, and then other new developments you hear about with height channels and things of that nature. If we look at this from a consumer entertainment standpoint, I think you could say there's a quest for realism. People have been saying that for hundreds of years. You know, this is really like you're there, or realistic. So that's a driver for all of this. And I like to say what's missing, and to me it's spatial reality, and also the use of more than one stimulus. If we're traditionally audiophiles, there's no picture involved. You close your eyes, you listen. It's the world of 2 speakers, and that's you're looking for your nirvana as far as the greatest whatever. But you could say over time, the signal to noise issue has been handled well, distortion well, frequency response, but getting a spatial reality type of presentation in the hands or ears of a consumer is not common today. There are ways to do it, but it's more of the, I got to work at it to get it that way. And we'll be talking more about this. I also want to talk about the value of standards. Some of you, I'm sure, have worked on various standards committees and organizations, observing that they move at a snail's pace. But one of the benefits of standards is that once it's set, and it's set, say, by what's called a consensus-based system, then manufacturers feel confident to build equipment according to that standard, because it's not going to be supplanted by something else very quickly. And that can bring prices down and goodness to more people. And then we're going to talk a little bit about immersive technology, a work in progress. Dan and I have continued to do more with this, and as time goes on, we'll explain more about that. Let's talk about the demonstration system. Okay, I have a computer here that's feeding the Shure video projector that you're seeing the image on. The audio from the computer is going into a little mixer, which is feeding a Sennheiser wireless transmitter. And you all have headphones on here, which I will say is courtesy of myself and Sennheiser. Myself, because Sennheiser didn't want them anymore after a show about 3 years ago, because it was too expensive for them to restock them. So if I'd take them, I could have them. So Dan and I have been sort of maintaining these for quite a few years, and we've got probably about 150, and we're just tapping a small section today. So there's myself and there's Dan. We're going to be talking, and you'll hear us through the theater PA. And then our friend Dexter, who's not in the chair but standing up front, will be a part of some live demos, which we'll get to a little bit later. So everybody being an engineer or interested in technical things probably wants to know about this demo system. It's a stretch to do things wirelessly because you don't want the system to get in the way of the demos. We've used this enough to observe that it works pretty darn well. The frequency response of the headphones looks pretty much like you see there. It has a desirable presence, a peak in the 3 to 3,000 hertz area, a little bass bump that's not too bad. Most people like it, and the channel separation for an FM system holds in there around 25 dB or so through quite a range of the spectrum. You all have headphones. Some of you had a chance to check these things out earlier, but for those of you that just have them now, just identify the parts. There's a subtle identification of right in one of the parts of the headband, and then the other one is obviously left, right? There's a power switch on one of the speaker sides and a tuning and volume switch on the others. We tried to set the tuning about right earlier, so the exercise is mostly going to be turn it on and try to set a volume that you might like. So has everybody found all the switches? And if you haven't,
what if we fiddled with the tuning knob, because we can help ourselves?
If you want to mess with the tuning knob, you can. I'm going to play some music, but it's pretty clear when the thing locks in place. Otherwise, it'll be pretty clear that it's not true. Okay, so first thing I'm going to do is this is going to play a left channel, right channel. So see what you get here. I'll listen as well so I can tell that it's working. Everybody okay on the left and right channels? Okay, anybody need any help on that one? Just raise your hand if you got a problem. Okay, good. Now some music.
One that's not working?
Yeah, this one's not working.
Oh, okay, hang on.
Just swap it out and see that.
Somebody has something dead there. Okay, let me go back to the channel identification. First, get yourself powered up. Okay, hang on, sir. We've got Reva hasn't got his headphones yet. Okay. You've been taking money out there, haven't you? Yeah. Okay. One more time on the channel identification here. Let me go into the play mode. Okay, here comes, should be left and right channel.
You got it now? See it?
Okay. Okay. And just a little music so you can get an idea what they sound like.
Huh.
Everybody,
try these. Could be it.
Everybody getting something that sounds like music? Okay. Now I'll make my excuse. For us older folks that have some hearing loss, this system will sound pretty noise-free, but some of the young folks here may hear some hiss once in a while. I'm pretty sure that it's not in the program, it's probably in the FM link. When you do some listening later in this breakout session, you'll get a chance to hear it in a wired mode. So the breakout sessions are going to allow you to listen to some 3D audio in two ways. One way is with earphones, and the other way is by a process we'll explain in more detail called crosstalk cancellation. It's two speakers, but its goal is to give you a 3D result. Okay. I want to talk now about some trends in 3D audio technology. I think we all know from the growth of the iPod rather, and all of its derivatives, that there's been a great emphasis on headphone listening starting in about 2000. There's also been a new emphasis on two-speaker 3D enhancement. In other words, I have 2 speakers, but what can I do to make it go to something that's beyond what I think of as traditional stereo? A number of companies have been busy over the years developing different types of technology, most of which they like to license to companies, that has something to do with these 2 kinds of technology. They're trying to take earphones and make the experience more exciting, trying to take speakers and make it more exciting. So we're going to talk a little bit about what Dolby's been doing, what DTS has been doing, what a company called Jawbone has been doing. Then we're going to talk about oralization, or a process by which you create, sort of from scratch, using computer processing, a 3-dimensional result. And a company from France called Longcat has been doing a fair amount of work there. And then Fraunhofer. Have most of you heard of the company or the group called Fraunhofer? Fraunhofer is a government-supported research agency in Germany, and they're the folks that started the MP3 audio format quite a few years ago. And then I'm going to talk about a new MPEG standard which was announced recently, which I think is quite significant. Okay. If all of you heard of something called Dolby Headphone, it's been around for quite a while. It's called Dolby Headphone. And it came out, I don't know, a good 10 plus years ago, where Dolby was saying, hey, we can take the multi-track soundtrack from a film and we can spatially place it around you where it should be if you were listening to speakers, and then you will get this you'll get this impression. And I have a demo we're going to play where we compare the Dolby Headphone soundtrack to the normal legacy stereo from a movie called Pearl Harbor. It was released on a DVD where they had both tracks available. So first of all, if you put your headphones on and click them on, I'm just going to play you a Dolby channel identification. So you should hear a left, center, right, and something in the back. So here we go. That's supposed to be mono. Okay, I looked for an official Dolby demo. I couldn't find one on YouTube. This is the best I could find. But this is using a process called Binaural Oralization, where each of the signals has a certain property to it if it's at this position in space. And they have the know-how to take that signal and position it there. So let's move on now to a demo. Now, these demos I'm playing not to prove a point, but I think we should discuss a little bit after you listen. So this is from the movie Pearl Harbor. You'll hear maybe about 30 seconds of a stereo track, the stereo, their mixed down stereo, and then of the Dolby Headphone. And first you hear one, then you hear the other. So I've got to switch to this movie, which I will do here. Let me close that. You might want to set your level again. I'll listen a little bit too. So here we go. It should be self-explanatory. We'll play a few cycles. It's a little longer than we want to listen. Okay. I made that with an open mind, but to be blunt, you couldn't sell me one over the other. Dolby Headphone has not been very popular, even though it's been out. And comment a little later on why this might be the case. I don't doubt that it was doing what it was supposed to, but what it was supposed to do and what's, let's say, exciting aren't necessarily the same thing. So moving on, recently DTS has made a move in the headphone area, very clever move, very well promoted, called DTS Headphone X. As far as I can tell, they're trying to do a Dolby headphone. There's a few different twists to it, but they have an app that was available on iOS and Android, and all the demos I have, I had to get off my app by recording off the audio from the phone because they don't have them posted anywhere else. So the first thing we're going to have is, which I think works pretty well, and it's also pretty cute the way they do it, the channel identification. They paired up with composer and arranger Hans Zimmer, who did the soundtrack for the movie Men of Steel, or Man of Steel. So here's a channel identification. So turn on your decoder rings, and here we go. I thought that worked pretty well. What I think is kind of clever is they don't go from front right to front right height. They come back to it. I do think height's rather difficult to judge, but nonetheless, I think that's a pretty good identifier. So now if you bought the soundtrack from the movie and put in a secret code, you could get the Headphone X version of all the songs. So I took one of the songs that I thought seemed to have interesting spatial sounding things and did some A/Bs. So first you'll hear what I call legacy stereo, and then you'll hear the Headphone X version. And again, I had to deal with taking all this audio off the files in my phone. So here we go. Oh, this is just a warm-up slide. There's Hans Zimmer, and there's the deal. So here you go. All right, now if you listen to the soundtrack, all the music is very swimmy. There's not much, everything is sort of enveloping to the whole thing. That was the most exciting I could find. And my reaction again was, if I didn't know which was which, I don't think I'd pick one over the other. And again, that's up to you folks, but they've been very clever not to allow you to make this A/B. You can't make the A/B unless you go through the work of downloading them both and piecing them together and so forth. So they've got a buzz going, and the buzz works well with their channel identification, and people have short memories as to what's been done in the past. So anyway, that's that. Now, moving on, this jumps a bit to the section that Dan Mapes Riordan's going to talk about, which has to do with crosstalk canceling. In other words, making a group of loudspeakers sound like it has a wider sound stage than you would expect. There's a researcher, he's a real rocket science. His name is Edgar Cholleri. He's with Princeton, and he's come up with some filters similar to ours that he calls the Bach filters, and he's licensed the Jawbone company, or the Jabra company, I guess it is. I'm not Jabra, Jawbone, and put this technology in this Jambox product. And I don't have anything to demonstrate, but just to say that that's out there. And it turns out that DTS and Dolby all have similar things. And a company called SRS has had similar things. They've been trying to promote these as licensable technologies for phones and tablets and so forth. Now we get into something that's a little more dramatic. This is from this French company called Longcat, and they're able to take a sound, put it in a room, change the distance, and change the orientation relative to a listener, and let you hear what they can do. And I think this is pretty interesting. So this is going to be a demonstration. It's pretty much self-explanatory, and you should hear some real motion and some different sounding spaces and so forth. So here we go with this one. Takes a few seconds to get going. So this is for people that want to create their own spatial audio. The blue guy is the head. That's kind of interesting. I mean, that really is dramatic. Techniques like this, depending upon how fast it could be realized, certainly would have an application in gaming, where the big challenge would be to decide where the listener is, where he's aimed, and where all the sources are. To my knowledge, not much has been done in a very sophisticated way in gaming right now, but this is a process that continues to develop based on the science of head-related transfer functions. In other words, if I know where a sound is relative to an average human, I can predict what the pressure would be at each ear. And then if I want, I could have that source hit a wall with a certain reflectivity and come back, so I could build a room. So it's pretty cool, and it's in many ways a solution looking for problems to solve. Fraunhofer has been doing a lot of good things, in my opinion. Through AES, I followed some of the key people there, Karl-Heinz Brandenburg and Jürgen Herr. Both have been very active with perceptual coding of two-channel information. And recently, MPEG, the Motion Picture Experts Group, announced that Fraunhofer's process had been selected as a part of a new standard, which I'll explain shortly. Here's the little demo that they're playing. That's obviously not technical, but gives you an idea what they hope will happen. Doesn't tell you a lot, but here's, and I don't claim to be an expert at this by any means, but I've been following it, and I know enough to be slightly better than dangerous. The thing that's been happening in this whole area is people have been trying to find ways to make, like I said, headphone and speaker experiences more exciting. And the techniques to do it aren't secrets, but the efficiency and the quality have been a challenge. Fraunhofer has started long ago trying to improve perceptual coding. Take one or two channels of audio, make it as high fidelity as possible at the lowest bit rate. And every time you can improve the bit rate, then that allows you to put it on more things, downloads faster, less memory, and so forth. So there's been a advanced audio codec that's been developed out of the MPEG committee. This is a consensus-based committee, and they've had a high efficiency coder for multi-channel audio. So you can put umpteen channels of audio on a stream and convey it to somebody to do something with it, and to do it very efficiently. So what seems to have been coming together now is this thing called the Extended HEAAC-based audio codec and 3D rendering engine. The rendering engine, to my knowledge, are the schemes that take two channels of content and do a crosstalk canceling routine to give you a wider image. And then they have a spatial engine that takes X channels of audio from where it's supposed to be and renders them to be in the right position. So the thing that will happen as more people adapt to this is there could be Program X, say it's a music program. It's available to download, and depending upon the unique part of your piece of equipment, you can do a binaural headphone oralization, you can do a crosstalk speaker effect, and so forth. And what everybody's been trying to do is the same thing, but Fraunhofer came up with the most efficient way to do it for a given quality level. And that's what this announcement that came out September 18th said, that the MPEG committee, International Committee, has picked their process. So I think we're going to see more of this now. The stuff that Dolby was doing and DTS was doing perhaps will fade away to whatever this thing becomes called. Singo is the word that Fraunhofer has been using. So if we should have time, I have some more details on this, but I wanted to kind of move along and give you a flavor of what I think is an important event. Okay. So want to do an immersive technology update now, and we would like to say that we're compatible with this new standard in the most easy way, and that everything we're doing involves just 2 channels. It's a pass-through. Whether it's going to be used by speakers or headphone, our process allows you to listen to this program with either format. The other thing that I think is important, or another thing that's important, is we have tools and we have artistic content. And you can make a Dolby stereo movie very boring. It could be mono center channel, or it could be very exciting. So the tools are one thing, but how you use them is another. And what Dan and I have been doing with Immersive is trying to use practical tools, but to try to create excitement. And that's what our focus has been. So a quick review now for those of you that are not familiar with what we call immersive technology. And by the way, most everything you're going to see you can find on YouTube if you go to Immersive, spelled AV. And we also have a website, immersive.com, that's finally taking some good shape now. So very quickly, this is a little story we like to tell. Picture a great room that has great acoustics, and you invite your favorite artist to come and play in the room. And they say, oh, by the way, why don't you come and join us? So you come and join them, and you get to hear them. That's what we're trying to do with Immersive from an entertainment standpoint, put you in that space. So this involves recording techniques, etc., to try to create a very exciting situation. So quickly, the science behind immersive technology has to do with how you record. This slide's sort of a mouthful, but it is making the point that if you want to make a recording, a binaural recording, there's a few places where you should put your microphones. And if you don't, you do not take advantage of the anatomy of a human. And you see where it says recording microphone. That recording microphone is located at the blocked entrance to the ear canal. And that also makes it convenient when you're recording, because you can have an earphone in there and hear what you're doing. But it turns out that the relationship between the sound pressure at that black dot, at that microphone position, and the sound pressure that would be at the eardrum if you took that whole contraption out, that difference is constant. It doesn't change with the orientation of the sound source. The orientation of the sound source is reflected in how that pressure changes at the eardrum because of the effect of your head and the pinna and your torso and so forth. And that upper left curve gives you some idea of how some of these parts of your anatomy affect that. The upper right curve is experimental data on myself, where I plot the difference between these two pressures for different orientations, and this has been duplicated by a number of other researchers, and it's no surprise. So part of the immersive process is to capture audio, whether it be with a mannequin or with a human at that position. The other observation is that today we can capture another sense, vision, that can be added to the sound for a definite synergy. The picture can tell you also where things are or where they are not. So even though audio focused people tend to close their eyes, we say open your eyes and look at the picture, because it'll help make the scene more exciting. Okay, you might recognize the actor who played Dexter. Dexter finished last Sunday. Anybody Dexter fans here? Watch Dexter?
I haven't seen it. Don't
If you don't watch Dexter, Dexter in the first series when they were on was confronted with a murderer called the Ice Truck Murderer, and he would basically cut people up and freeze the parts, and they'd find them. So you see Dexter, he's a forensic technician. He's also a serial killer. Anyway, the mannequin that I have up here is a modified fiberglass store dummy, very similar to a Kemar, and since he all comes apart, I've called him Dexter. And the D stands for dual channel electroacoustical transducer for electroacoustic research. So there's an acronym there. That's Dexter. And he rode with me tonight in the car. So what we're going to do now is do a live demo. We've got Dexter set up here, and he has 2 live microphones in his ears. So I'm going to ask Dan to be the talker, and we're going to try a few different things here. So I'm going to have Dan stand in front, turn Dexter around so he's facing me. Just rotate his torso. That way it'll be as if you're in Dexter's position. There you go. Okay. So Dan, if you can now, that's good. If you could now go up in front of, and now if we could mute the PA, I'll just talk loud. Yeah. You get your earphones on. Don't turn them on too loud or you get some feedback. Yeah, get some feedback. Okay. So you should stand in front of Dexter right down pretty close and just talk right in front of him.
Testing 1, 2, 3. Joe took father's shoe bench out. Check 1, 2. Check
Okay.
1, 2.
Okay.
How do I sound? I'm too low myself.
Yeah, okay. Now go, and if we listen bigger than life, we hear room tone. So go and talk in each ear and
Sure.
up
Now I'm
fairly,
going to move
up fairly
around.
close.
Oh, I hear my shoes squeaking. Do you hear that?
Right.
Yeah.
Check
Right.
1, 2. Check 1, 2.
Yeah.
Now I'm to the
Yeah.
left. And now
Yeah.
I'm coming in closer. Now I'm in closer. This sounds really weird because I have my headphones on as well. So
Yeah.
I can hear myself coming around.
Right.
Now I'm going to go around. I'm gonna go all the way around. Testing 1, 2, 3,
Right.
4.
Yeah.
Joe took father's shoe bench out.
Yeah.
Check
Right.
1, 2, 3, 4. Testing 1, 2, 3, 4. Now it should be right on your right ear. Check.
Now, here's something I think is pretty cool. Let's listen to the sound of one ear. What I'm going to do is I'm going to turn off his right ear, so we only have the left ear, but I'm going to put it in both channels. So right now, if you go on his left side, Dan, and talk in fairly close.
Check 1, 2. Testing 1, 2, 3, 4,
Okay.
5. Check
Okay.
1, 2. Check
Okay.
1, 2 is the mono source.
Now go around to the
Now I'm
other
walking
side.
around,
Yeah.
now I'm in the back. Testing 1, 2, 3,
Right.
4, 5. Joe
Yeah.
took father's shoe
Right.
bench out.
And
Test
just
1,
move
2.
up on the.
Now it sounds very
Yeah. Okay.
here I don't have much direct sound.
Right.
No, I don't have front. Now I'm
Yeah.
directly in front. Testing 1, 2, 3,
Yeah.
4, 5. Test 1, 2, 3.
Right.
Check,
Then-
check.
Then if you talk in front of it and just a little bit off to one side, that's about where the human head's
Testing 1, 2, 3, 4,
polar
5.
sensitivity is about the highest.
Test
Sometimes
1,
when
2,
you're
3,
trying to
4,
hear
5,
somebody
yes.
talk that's on one side, you'll cock your head a little bit because that's where your directivity is the greatest. So this is what happens. This is what one ear sounds like. Okay. Sometimes people have a dead ear. And then it's very disheartening if you have a dead ear, because when people are on the other side of you, you don't hear them very well. So sometimes they have a hearing aid apparatus called a cross, where they put a microphone on the dead side and feed it to the other ear. So it's all mono, as I will do now, but this is what it would be like if you had, let's see, only your left ear is working. So, okay, this is the left ear working, and I'm going to pan the right ear to that. So now when he goes and talks on either ear, it'll both come out on your left side. So go ahead and
Testing 1, 2, 3, 4, 5. Check 1, 2, 3, 4. Now I'm at the left ear. Test 1, 2, 3, 4. Now I'm going to move over to the right ear. Testing 1, 2, 3, 4, 5. Check 1, 2, 3, 4, 5. Now I'm moving towards the right ear. Now
right. So that would help somebody that has a dead ear, called the cross. Okay, well, we thank Dexter. Maybe I'm going to get him a t-shirt, a Dexter t-shirt. He's used at times for recording. So we can bring the our PA up now, please. Okay. So that's Dexter. At this time, I'd like to play some short demonstrations of things we've been doing that are using regular binaural. So there would be either a dummy head or a real head as the recording, and we're trying to capture some musical event in the most exciting way. And the first one is a friend of mine that came over to my house one day that wanted to hear some demos. So he and I were just playing around, and his name is find him here, Dominic Bally. So here's a quick little movie of him coming into my house, and it'll be obvious what we're doing. There's also a little demo that things move around your head. Now that was, oops, mostly to show some of the things you can do that you're not used to hearing, which are particularly things that move off to the sides and somewhat behind you. And the idea here is to try to bring that more into a musical presentation. This is a little more of a serious, this is just a single classical guitar player, so it's mostly person in a room and it should sound pretty natural to you. This is a local Chicago area jazz musician, John Mulder. I'll just play part of this because we're going to keep the time here in good shape. I was wearing the microphones in this demo. Okay, so that's mostly listening for naturalness of the guitar. It's pretty much the way I heard it, and this was in a church, a fairly big room, and not a terrible lot of reverb, but pretty pleasant sounding. Here's something that has some obvious moving sound sources, mainly by me, the camera operator, moving. Well, you might say it's a little hokey, but you can hear the obvious effects of panning the music around in a way you're not used to hearing. I'm going to play one more before we move on to Dan's part. This is a classical bit. This is Vivaldi's Winter, and I'm going to jump to the, if I have the part of the song that is most recognizable. So I'm going to skip over some of the things here. Let me just move to, this was recorded at the Unitarian Church in Evanston last December. That's Dexter. Okay, Dan, we're finally getting to your part. Something that Dan and I started working on a few years ago was, could we take these binaural recordings and figure out how to get a reasonable, not reasonable, a realistic binaural result through loudspeakers. And Dan has done all the heavy lifting on this. By the way, there's a whole YouTube little story on this that you can go to and find. So at this time, I'm going to introduce Dan Mapes Riordan, who is going to talk about this issue. Dan? Where the slides are, and here's your pointer.
Hit a page down.
Yeah, there you go.
All right. All right. Well, thanks, everyone. Bob asked that we should spend a few minutes going, maybe look under the hood to see how crosstalk cancellation works. I'm not going to spend too much time on it. It's getting late, but I do think it'd be interesting to go through some of the details and what it means to do crosstalk cancellation, some of the issues involved. Before I get started, though, let's take a step back and ask why. Why would we want to do this? The main reason is we'd want to be able to play binaural content that was intended for headphones or earphones and played over loudspeakers. How many people have heard binaural content before? Can you raise your hands? Just like most people have. How many people have heard it over loudspeakers? Quite a few people, maybe a little bit less. Yeah, so it gives you a sense for that. I remember myself, the first time I heard it was, goes to the why question. I think the first time I heard it, I don't remember the details. I forgot to talk to Bob about this before this meeting, is that there was an AES meeting maybe 20 years ago at maybe WFMT. This is what I'm thinking of, and that was maybe about the ER4s, the automotive ER4s had just come out. And I remember Marty Wilde, people remember Marty Wilde had some Kemar recordings that he had made in the lab. Was anyone there at the same time as me? So I wasn't imagining this. It's been a while, right?
It's the old studios. It's not the one that they're in now.
Okay, it was back at the old studios.
At 3 Illinois Center.
That's right. I couldn't even remember where it was, but what I do remember from that meeting was that I heard binaural content that really worked for the first time, listening to Marty Wilde's Kemar recordings through ER4s, and I was like, oh, being a relatively new audio engineer designing products, it was like, I just heard the holy grail of what audio can do. And so the big question of why is that whenever we hear binaural material, and I play it to a lot of people, just people up, the street, family and friends, that type of thing, they get the same impression. It's like, wow, if you play the right material, it's like a light bulb goes off and goes, wow, that sounds great. I've never heard anything like that. So that's why we're all here, right? Is because this is a really cool technology. It works best. I kind of feel like it's a holy grail. But let me get to some specifics here. Is that the reason why we go to crosstalk cancellation? I'll call it CTC for short.
There's more playback opportunities, obviously. And one other technical point is that what I found in my experience is that when I'm playing binaural material through earphones or headphones, the frontal images quite often collapse to like right here. And when I play them over loudspeakers, they never collapse for me. We can talk about, maybe afterwards we can talk about the details of why that might be, but essentially I get much stable frontal imaging with the loudspeakers. Here's just a list, a select history of crosstalk cancellation, or CTC. It's not exhaustive by any means. There's been a lot of work in the area, but most people point to Bishnu et al. And Manfred Schroeder as the beginning of it. They were working at Bell Labs and they applied for a patent on it in 1962. Anyone remember Cooper and Bach, Dwayne Cooper and Jerry Bach? In the 90s, they called it transaural, and they were using a little bit different method. We'll get into a little bit about that. In the 90s, Bill Gardner at MIT did his dissertation. I think he even made a book out of his dissertation, 3D audio over loudspeakers or something like that. Where it really started to get interesting, in my mind, is Kirkeby and Nelson and others at the University of Southampton in the late 90s. That's where they started developing some least square error solutions, trying out different speaker topologies, and realizing all the design trade-offs that are involved. Just to go forward, we get into 2000s, Taguchi and Nelson. Again, Nelson came up with this realization that for minimal spectral coloration,